Greetings. Today we'll be talking about we're going to be reviewing like inheritance, and we're going to just go through sort of two real life examples. One will be the like clothing, looking at various pieces of clothing and how they might associate with each other, um, and then we're going to generate game pieces and figure out how we can categorize them and sort of tie them together and what parts might be shared by a game piece. All right. So yeah, so let's check in. I'm able to SSH into Jeff's server. There are two students logged in. Jeff's website is up. Hopefully you've looked at assignment 8 and are on your way for finishing it, and you've taken a peek at assignment 9. And let me know if you have any requests. Okie dokie. So for clothing, and I just started typing this up, but that maybe you have this super class or you have the parent class of clothing, and it has private parts like material, number of holes, or maybe location worn. And maybe this location here, this is yet another class, some kind of enum um, that has head, or top of head, face, neck, torso, waist, pants, whatever, or lower part, so that it has a location that could be then used, and that in general you could that this clothing is general enough that it can handle all of the different parts. But then these subclasses or these children classes um, would inherit from clothing. So when they inherit from clothing, they would get this material, number of holes, and location. And even like a shirt may have this set. All shirts may have the same number of holes and be worn in the same exact location. But they would have additional things that would make it a shirt. So not only do these the shirt be a child of this clothing class, it may have additional things, but also it could have these private elements set so that they don't change. And then this shirt may be the parent class of, let's say, a t-shirt and dress shirt, and that these, imagine maybe we're selling clothing, and that people send us designs, and then we make the design and send it to them. So maybe this is the back end or the front end of their website. So when somebody says, yes, I would like to buy designed clothing, and it's going to be a shirt, and it's specifically going to be a t-shirt, these are the kind of things that you might ask. Oh, maybe size, maybe for a t-shirt, because there's set sizes, but also, right, these, so like the t-shirt might have a different size classification than a dress shirt. I've noticed that a lot, is that the measurements for a medium dress shirt versus a medium t-shirt are radically different. And so those might be the same, but then when you look at pants, that the sizing for pants, that there's multiple sizes for pants, right? There's the waist, there's the inseams, there's all kinds of things like that. So that we might say the word size as an attribute that we give these things, but that what they are not synonymous. That the size for t-shirt might not be the same size for dress shirt, and so you might make helper methods to translate between them. If such, for shirt at least, that maybe all of them have there's some kind of standardized sizing in the main shirt class, And then each of these subclasses has overloaded and made some kind of translation to this shirt so that you can then compare a t-shirt to a dress shirt size. So that if you had an instance of a t-shirt class and a dress shirt class, that you could compare them in some way. Um, but this is, I mean, this is just sort of just a thing to work through in your head. That you just look, I literally just like looked to my side and saw a t-shirt that I'm folding and was like, well, this would make a great example for a class. That you should be able to do this with all everyday objects. Just look around and see what kind of relationship that you can tie to these things, and then come up with, what are the attributes that they have, what kind of shared attributes might they have, and then um, what makes them different. And then if you can sort of silo them into discrete classes, um, and sometimes it's not as obvious as the pile of t-shirts versus the pile of pants, um, but I encourage you just to think about it. And it depends on how you want to group things together. Maybe you want to interact, maybe you have a class of all of the things of a particular color. That's the class. And the color red. And then that you have tons of subcategories below that. Maybe you're doing inventory on a set design, and you need these classes to be able to help break things down, um, to be able to find them. um, yeah, so just a useful sort of thing to think about. And that maybe the and like with the location, right? Location, we sort of came up with a list or an enum of things that locations that it could be, um, but that we can have other types, right? These designs um, or some kind of image. So these would be some kind of class bitmap or something like that, or something with the logo. And the color, right? This color could be represented as a byte array. Um, I mean, it could be represented as a hex value. Um, so an unsigned thing. Um, the booleans, right? For is it like the socks? Are they liners or are they ski? Um, and you could make subclasses for those, eh, but yeah, that you could have a boolean type. So don't just think of everything as strings, as being like descriptors or something like that. Think about how you can group things together, um, or of how you can use the various types to help explain what things are, right? The size, we talked about the size, the size for pants would actually probably be another class, or some kind of other structure that can hold multiple things. That you might say pants dot size dot inseam, and then that itself is maybe a double, or maybe it's just an integer. Right, if it's getting tailored, then a double makes more sense. But if you're just buying it off the shelf, then for the most part just a normal unsigned integer would be fine. um, yeah, so as opposed to the size for t-shirts, uh, that would be like a restricted set of things, right? There's the small, there's the medium, there's the large, the extra large, double XL, triple XL, whatever. So that there's this with the t-shirts, that there's this very nice set defined size list that you're going to offer. But with pants, that there's sort of this wide range, while still finite. It's you're not going to make you're not going to use strings for all of the various pant sizes. Um, And then for hat, maybe you say, maybe you could have another thing of, a Boolean of is baseball cap, is beanie, is things like that. And the idea being is that maybe you have a baseball cap beanie, then you could have them both true. Or that you have some mix mash. Does it have a little whirly-gigger on top, the little fan thing. Does it have a little whirly-gigger on the top? I've seen beanies with the little whirly-gigger. I've seen baseball caps with them. So that might be another Boolean that you might use to express a hat. And then for the size for the hat, right? Do you have the size of in this case, the size is actually going to probably be a range. Most hats have some kind of elastic or adjustments to them. So you'll have a lower bound and upper bound. But then there's the physical size of the hat of how much space does the hat actually occupy? Is it super duper tall? So you have multiple size elements of the hat. And then depending on what you're using this class for, right, you might have actions of, I mean, in our real world case, we might have, put the shirt on, take the shirt off. But in the case of this, it might be setting these designs or ensuring that they're, maybe we take in a design and then we lower the quality, because maybe that's the best we can do when we're manufacturing it, and then we're able to, and then there's getter methods to be able to return what the design is going to look like, superimposed on the shirt. All right, a lot of websites, when you're designing, doing this designing, that you'll upload a picture and then you'll select the sort of the quality level, and that you can sort of see real time what it's going to look like. So you could do that, right? You could make a t-shirt class where they upload this front, back, and sleeve designs, and pick a size, and then you call the method to get it back, and it has the image on the front and the back and the sleeve, and it shows you what it's going to look like. So those could all be methods. Okay, cool. So yeah, so that's just sort of a little mental exercise. So let's do that. Let's do that again for game pieces. So let me just open up a text document. Alrighty then. So yeah, so let's just think about game pieces. What kind of game pieces do we have? So let's make a generic. Let's make the parent the super class of the parent. So it'll just be called what, game piece. And in general, maybe we have, maybe we just care about the material. And then what other, let's think of a game board. Let's think of Monopoly, for example. So let's think of like specific kinds of game boards. So you've got like you've got the like the iron and the cannon and those things. Those are representing the player, right? So there's a player piece. And actually, let's just go through the things on the Monopoly board. So then you have the board, right? What else you got in Monopoly? So we've got the player pieces, we've got the board. Maybe there's some kind of a currency, if I could spell. Currency. I'm using Google to check my spelling. Yeah. Okay, currency. So some kind of in-game currency. All right. Let's see what else. So yeah, so okay, so Monopoly. So we've got our player pieces, we've got our board, we've got our currency. Um, there's dice, right? You roll your dice. So we could just wrote that we have like this roll dice. Um, so that's a method that just popped up. Um, and then we have like the hotels, and like the houses and things like that. Um, so I guess we could classify those as like markers. They're physical markers on the board of some kind of attribute or changed to it. Um, and then there's like the chance, and then there's the other cards. There's the two kind of cards. So we have our cards. Um, sure, I'm forgetting something on the Monopoly board, but let's start with that. That's probably a good start. So some of these things um, might have some commonality to them based on the kind of game that you're playing, right? That a marker might move or might have the same kind of things that a player has. Um, and even cards. There are a lot of games um, where the cards do things that are very much like how the player would do things. Sometimes the card physically represents the player. I mean, we think of some game like Yu-Gi-Oh, right? You can have cards that flip upside down, or even in Magic, like the Morph ability, cards are able to flip around. Um, even if we look at something like Texas Hold'em, that the cards go from face down state to a face up state at the end of the game. So you have this sort of flipping um, interaction. Um, so let's do that. Let's say, well, maybe you have a coin that also flips, and that coin could be a marker. Um, right. There could be a sub thing for like a coin, or like a hotel, house, those kinds of things. Also, a dice. Um, sometimes with dice, that those you don't roll them. I played a game where you get to select which side of the face is the one that you want to be active, and then you place it. It's like a counter, and then you place it on the board. Um, but also dices are used for counters. So you have like sort of like a set value. I'm just spitballing that's the idea, is that in this case we're coming up with all of these classes, and we're just trying to remember games that we've played, or games that we've seen played, um, and think of how we interact with things. So, um, get total, you know, add, remove, things like that. The board might have spaces, size, um, and that each space might be another class. Right. So now you have this array structure. where you have this spaces class. Depending on so the board is made out of a material, but that maybe we set that material for the board, but that it's all good. Um, and we may start noticing that some of these have that some of these you may interact with in the same way. For example, a player piece is going to move, like a marker might move, or that a card might move, or that they might flip, or they might rotate, um, or that you might add a player to the board, or that you might remove a player to the board. Same thing with a card or a dice. That they all have these sort of similar interactions with each other. There are games where the currency isn't sitting in a bank or sitting like with you, that maybe there's the currency and it's sort of floating around um, on the board, and then it gets added or removed, or that it or something happens to it. So we might be able to yet group some of these things together again. So we're assuming here that all of these guys have a parent of game piece, but it's possible, if we recall from 2 weeks ago, to have these also have an interface. So let's just make a generic interface. Maybe instead we make game piece. Actually, let's just make an interface. Let's call it item. I don't know. I could probably come up with something better, but I don't know. So we make this interface. We'll call it item, and that it can do things. So let's just think of in general, what can you do with an item in the scope of a game? So we can place the item, we can move the item, we can rotate, we could flip it, we could remove it, we could add it. So instead, these could all interface item, right? Or some of them. I mean, I've seen games with multiple boards where the boards have weird interactions where the board comes into play. There's games where people could walk in at any moment, and then if you hit a certain number of people in the game, then it actually would add additional boards or additional cards and things like that. So even a board could have this item interface. And currency, right? That we've already mentioned that currency could have these interactions. That the dice could have. That I've seen games where dice moves around the board along a particular path, and that rotate could be there are dice that instead of the numbers on them or the dots on them, that they have symbols on them like an arrow, and that the dice could be pointing towards something. So the rotate could be interacting with that, but the roll might still be an action that you do in the game. That flip, that there's on most dice that on the opposite side is something of an opposite value, or some kind of weighted opposite effect. Like you look at like a D20, that what's on the opposite is depending on, like, if it's a roll down versus if it's a standard dice, that it's evenly balanced. Cool. So let's see what else. Yeah. So in this case, we have this game piece as a, and we can really move material into this interface. But maybe we want to have all of these pieces um, connected in some other way that the game piece class does. So we could just have um, the material as an interface of have it as a private part of the interface item, and then we can entirely get rid of game piece, or we could just make the interface instead of item, make it game piece. And that's something you should always look at is how can we simplify something like this. Um, Granted, we are sort of overcomplicating something like this in the scope of game pieces, right? This could be just some text file or something that stores all of this stuff, and then maybe we don't care. But um, maybe we're a video game company that makes online board games, and we want to be able to use these set classes to be able to cover all of the games. Um, so that then to be able to make, if somebody wants to make a game, they can essentially select, they could have these pull down menus that says, make a, create a game piece, um, create a game piece, and then it says, okay, cool, what material do you want? What kind of game piece is it? What is it representing? And then maybe they upload designs or something, and so then maybe the interface has some kind of design part. So we know the material, but maybe we don't know the color, or we don't know, like the board. Hopefully, the board has a really cool texture to it, um, and then maybe they have some kind of XML map or something that they upload that indicates what spaces belong to what. So you have the number of spaces, but then maybe you have some kind of XML um, of the map of the design, um, right? So the idea being is that somebody could make a game without any knowledge of programming, that they could essentially use all these pull down menus and be able to type text boxes and be able to upload pictures and things, and be able to make a game. So that you could do all the programming in advance. Some of the game logic may be fairly hard to be able to write, but that if you do a good enough job of making the outline, that you could do something along the lines of like code blocks. If any of you are familiar with code blocks, or not code blocks, totally brain farting. Not code blocks. Code blocks is an awful IDE. There's a drag and drop coding. Let me go Google it and try to remember what it was. I'll be back. All right. So yeah, so it was like code.org. It has this sort of drag and drop interface where you're like move forward, drag here. So the idea being is that if you write out all of those classes good enough, that being able to have interactions like this that are nice, well defined, somebody could take the rules for a game like Monopoly and be able to essentially construct the rules of how a player is supposed to interact, or maybe even the AI, how the AI is supposed to play by just dragging and dropping things. Um, but this is Scratch here. This is very common. So that's pretty much based on. Um, but there's all of these. Like this one doesn't even have words. It just has arrows and symbols and whatnot. that you could just entirely do a drag and drop um, to be able to play the game. So yeah, so that's why, because that kind of interaction is much easier to do. Why is that not opening? There we go. So if you do a good enough job of defining all of these, then you could suddenly make it so that people could program video games without having to need to know a good amount of programming. And one of the sweet things about most of the interfaces is that you can see when you do that drag and drop to be able to sort of plug everything in together, and the customization of things, that you can then go, especially in Java, you after you do that, you could view what the code would look like. There's a program called Alice that was made by Carnegie Mellon that allows you. That was before that sort of Scratch, where you could drag and drop things, and you could do sort of a lot of the activities that you see on code.org. Like code.org has like the, you know, Elsa from Frozen, draw this shape or whatever. Um, um, while ice skating around, and in Alice, that there was there's like the ballerina, and you could do the same kind of things. And the idea being is that it helped you get familiar with objects, um, and it had a sort of generalized thing. So you have like this people object, and that people is, and that there are sort of there are lots of different subtypes of those people. So there are these children of this superclass, and they have attributes and they have ways of interacting, um, and that you could drag and drop to be able to make them sort of interact with each other, and that you could then go and view the code. So one of the nifty things is that while you could iron this all out, have like a Scratch kind of like drag and drop environment where they could code up game logic. If they then wanted to say, okay, well, what is the Java code that got generated from this drag and drop, that they could then export that and view that, and that would just be part of it. So you can sort of hide while people are designing the code to try to make it not super intimidating, but then you can reveal it to them whenever they want to. So if an experienced programmer comes along and says, "Oh, it would be easier for me just to type this all out instead of having to drag and drop it," that they could go into an interface where they could then go and type in all the code, or they could do something, or maybe it's just like they need to figure out how things are sort of connected to each other. So maybe they use a drag and drop environment to just drag and drop all of the objects in the world or whatever, and then they view the code from there, and that's sort of good enough for them to figure out how to code how to code the whole thing. They just need to know how things were called. Yeah, so that's just something to think about, for game pieces, is pull out a game board, figure out what I've missed. Let me know. Um, can comment in the video, or you can send me an email of if I've missed game pieces or types or things like that. I'm sure I've missed tons of methods or private parts, but that's a good activity for you to do mentally, and maybe even just writing it down. Um, and that if you have a class that has a final project, like a portfolio final project of anything you want to do, anything that you can do, um, maybe doing something like this where you make something very, very generalized. Maybe you want to do Monopoly, but at first you make this very generic thing, then maybe you don't use all of the methods that you wrote, because you generalized it for all of the games you could think about. And it's going to be difficult to cover every single game, because sometimes, a game will come up with some kind of novel way of interacting with it with a very traditional piece. And one of the nifty things is that APIs can evolve. So if, for example, um, so like was unhinged in Magic, there's one card in all of Magic that you shred the card and throw it onto the field, right? And so, if you think about it, there's over 9,000 Magic cards. There's probably, there's well over 9,000 Magic cards. Um, do you rewrite the entire? Do you rewrite your class to be able to handle that case, right? If you're playing, if maybe there's Magic the Gathering online, do you just say, no, we're going to remove that card from the game just to make it easier for programming? Or do you add it? And when you add it, one of the nifty things is that you can add it by just adding another method, and you don't have to risk breaking all of the code as long as you keep the API the same, except you're adding one method. It's when you go the opposite way, when you decide that you want to remove that method, that you also have to ensure that you removed everybody that's using that method, because otherwise somebody somebody draws the card and they can't call it, or that they try to play it and it calls a method that doesn't exist anymore. So it's always, you can always add to your API, but that I encourage you to be as very cautious as possible when you're removing things from an API. Ideally, you shouldn't remove things from an API, but sometimes it happens. Sometimes you want to simplify it, but just be mindful. That's definitely when you start breaking things. For example, the Swarmy code with the robots that I play around with, that somebody was trying to clean up some of the code that I written, and they essentially went in and deleted a ton of helper methods that I wrote, to make it. I wrote them all to make it as accessible as possible for students, and somebody went in and removed all of it, and surprise, surprise, it broke a ton of students' code because that wasn't there anymore and they were using it. So, making sure that if you do remove things from the API, you should definitely inform the people who are using it, and maybe give them some justification of why. And there wasn't a good justification in my case, but yeah. Yeah. So a little bit of API, a little bit of inheritance. We've got a few minutes. Let's see. Yeah, so let's just quickly write up what this might look like. So I don't know. Let's see. So let's make our interface. Okay. So let's give it a name. So we have our item interface. Okay. Of course I can get it to. So it's always good to have our toString, and then our prints. And what other things we had? We had our place. So maybe we return Boolean. For place, and that place takes in, maybe there's a location class. So we'll just make a note, need a public class location. Okay. That we would then use this as the as an element of the space. Okay. Then we have our move, and this could be another Boolean. So the Booleans are whether or not they happened, right? In chess, for example, somebody might try to do a move, and you might say no. You might return false, and then they can know that the board needs to go, that the board either needs to or that it's already been put back into its original state. And so again, this move might have a location. And we might overload it. You might have a Boolean that is, we already have a reference to the item itself because we're interfacing with the item, but that, I don't know, I'm trying to think of if we should overload it with two locations. The instance should be unique. Yeah, okay, so we don't need that. And then let's see what else we have for this interface. We had our rotate. So we're going to have an enum. So maybe we have an enum of the direction. So let's recycle that from a previous activity. So we have our rotate. And again, let's just make it a Boolean, whether or not that rotation is legal. The reason being is that, you know, think about in Magic, when you go to untap, right, which is a rotate option. Sorry about the noise. When you go to rotate to untap, if you try to do it during the wrong phase, somebody's gonna be like, no, you can't do that right now. So, yeah. Okay. Let's see what else we got. So we've got our flip. And in most cases, the flip should be fine, right? So we just flip. But there's not really, you're gonna just flip it. You're not, there's no extra parameters or arguments that should be needed. I might be wrong, but whatever. And then we have our remove, and we have our add. So this could be, you know, the remove. Remove and add, actually, if you think about it, I don't know, that might be to a board. Or you might use it to zero out parts of the item. Maybe there's a Boolean on board. And so then when we go to add and remove, all we're doing is we're just going to set this Boolean. So we just do something, you know, like, something like that. And then what we return would be based on whether or not it was on the board or not already. So we might say if this is true, then we're going to return false. Let's set this. There we go. And so then if we're here, we know, if we're here, then we know that it's not on the board yet, and then we set it. And so then remove is going to be very much similar. Except we're going to flip it. Yes, I am mixing tabs and spaces. Okay, so if we say false, and so keep in mind, we can get rid of this. I just wrote that so that it was clear. So if not on board, we're going to return false, as in we couldn't remove it. And then we're going to remove it, and so that's going to be false. That's true. Sorry. Okay. There we go. So there's our add, our remove, something like that. And then let's see what else we got. So those are the initial interfaces that we wrote up. How are we doing? Okay, good. A second. And then essentially these, so that's the interface. And then for something that was going to then use the interface, we just say implements. So we would say something like public class. We could say board. And on board, maybe we say like on table or something more like that. I'll have to think about that. And then we say implements and then item. Okie dokie. Actually, let's do dice instead. And so dice also, normal. No. Okay. So dice is going to implement item, which means that we have to write the code for all of these. That's a really important thing about when we say implements, is that even if we don't intend on using those, on using all of these for that particular, and actually, sorry, this would be, so actually add, right? So add and remove, I got carried away. So add and remove for dice. And so this here, this add and remove, we might have another interface, or we might have a parent for objects on board. And then the idea being is that then we can just inherit from that and we can get this method without having to rewrite this method for every single public class, or for every class that's going to be on the board. Yeah, so I think that's enough talking for me. I'll throw this will put onto the slide, and then this here I'll stick onto the GitHub page. Yeah, blast me an email or message me on Slack if you have any questions.